Okay, this is Mr. Weideman, and this is pre-calculus. I want to go over these homework example problems in a little bit more detail. Went through them way faster than I wanted to, so I'm going to go over them a little bit more slowly. This is the first type of problem that you're given. They'll give you a polynomial, and they'll ask a question like, is x minus 2 a factor? Well, one way to do this is I could take x minus 2 and I could use division. In this case, I could use synthetic division and divide it in and see if there's a remainder. Okay, that's kind of the hard way. What we're going to do is we're going to use something called the remainder theorem. And it basically says this. I'm going to take the constant of my factor. Okay, in this case, the negative 2. Or in this case, excuse me, the 2. And I'm going to plug it into my function and see if y equals 0. So that is exactly what we're going to do. Now, why do I do that? If I plug the 2 in and it equals 0, then yes, x minus 2 is a factor. If I plug the 2 into my original equation and it's not equal 0, then it's not a factor. Okay, so let's do that. We plugged in the 2 into our equation and we get a 0. That means that the answer to the question is yes, x minus 2 is a factor. Now in your homework, I don't want to just see yes and no. I want you to see that you plugged the constant into your equation and did it equal 0, yes or no. Okay, the next type of problem that you're going to be working on is something along this line. Again, you're given a polynomial. And then along with the polynomial, it says, I want you to find the max number of zeros. And this is extremely easy. The max number of 0 is just the degree of the equation. And then after that, then it asks us to use Descartes and estimate how many of the zeros will be positive, how many of those zeros will be negative. Okay, let's do the easy part. The easy part, the maximum number of zeros is going to equal to the degree of the polynomial, in this case 3. Okay, now let's use Descartes. First of all, let's just leave the equation alone to do anything to it and count the number of sign changes. 1. One sign change. That means I have the possibility of one real positive 0. Okay? So that's one possibility. Now remember, I have a possibility of 3 zeros. Okay, what about the other 2? Okay, well what we do is we plug in negative x. Very, very different than negative of the equation. All right, pay attention here. And then when we simplify this stuff, now we see we have 2 sign changes. What does Descartes tell us? Descartes tells us that I have a possibility of 2 real negative zeros with a huge wait a minute string. The 2 can be subtracted by an even integer and give us 0. So I have another possibility. There might not be any real negative zeros. So how do I answer this question? What do I write down? What do I need to see? I need to see that you did this. Okay? I need to see, did you count your sign change? I don't care about that. And then I need you to answer this, this, and this are your answers. This is show me your work. Okay, one last type of problem. Okay, so again, given a polynomial. All right, in this, we want all the potential, all the possible rational numbers that could be zeros. Now, how are we going to do this? All right, this is a little bit different than all the other 2 problems. And we are going to use the rational zero theorem. Some trig teachers and algebra 2 teachers call it minding your P's and Q's. All right, so the potential zeros is this. And you go, okay, well, where did I get that? Well, the x minus thing, I'm going to discuss that in a little bit. All of these guys here on top, those are the factors of the tail coefficient. These guys come from the lead coefficient. Okay? And so this is kind of our answer, but we need to simplify it a little bit. Now, all this plus minus 6, plus minus 3 over blah, 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 blah. What does this really mean? Okay, well, that section actually means this. The 6 divided by plus minus 1, 2, and 4. The 3 divided by plus minus 1, 2, and 4. The 2 divided by plus 1, 2, and 4. So on and so forth. That is what that actually means. Okay, the 6 divided by everything in the denominator, the 3 divided by everything in the denominator, the 2 divided by everything in the denominator, so on and so forth. Now, a lot of times, it's not necessary to do this step. You can just do this in your head. And what happens next is each one of these guys, then I go to simplify. And again, you don't have to write it out. A lot of this can just be done in your head. Now, why do I do this? The reason we do this is now we can eliminate a lot of redundancies. This thing is saying the same thing. So I cross out all of my redundancies, and then here is now my possible zeros. And that is the answer that you have to get. Now, what about this x minus thing? What the heck does that mean? All right, these are possible factors, possible zeros. So they actually look like this. The plus or minus 6, that means x plus 6 or x minus 6 can be a factor of my polynomial. The x plus 3 or x minus 3 may be a factor of my polynomial, so on and so forth. I would actually have to test through synthetic division. But that's what it actually means. What do you have to give me as far as an answer for your homework?